Hello everyone. The reason I'm doing this video, it's because I've noticed many times Bernoulli is used to explain why planes fly. The truth, this is not incorrect. Bernoulli is not incorrect, but it's not sufficient to explain everything. Because with Bernoulli, you can't explain how planes can fly upside down. It doesn't explain the shape of wings, and it doesn't explain how an acrobatic aircraft can fly with symmetrical wings. So that is why I'm doing this video, because honestly, I have been looking for a video explaining that, and the last video I could find was made in 1941 by the US Air Force. And actually, if you want to see it, it's a very good one. Please just write these words: aerodynamics forces acting on an airfoil. If you type that in YouTube, you'll get a 1941 really good video on the subject. I'm sure you heard about Bernoulli explanations. You always get a diagram like that. In these diagrams, you've got your airfoil or the wing in the middle. You've got airflow going at the top, airflow going at the bottom. They tell you that the airflow at the top of the wing needs to cover a longer distance over the same amount of time as the airflow at the bottom. Hence, the speed of the flow at the top is higher than the speed at the bottom of the wing. And Bernoulli says if speed increases, pressure drops. You can actually do a very simple experiment. If you blow air between two sheets of paper, you're going to see them going next to each other because the pressure drops. So that's Bernoulli's explanation. The problem with that, if you want to know, if you calculate using Bernoulli theorems, how much longer the top part of the wing needs to be versus the intrados, how much longer the extrados needs to be versus the intrados for a Boeing 747, you do end up with a wing which looks like that. You need an extrados which is 50% longer than the intrados. And believe me, Boeing 747 wings don't look like that. So, the problem with Bernoulli is that there is no lift created actually using this way. This is just not the way it works. In other words, you need to look at what Newton, another great physicist, how Newton worked, and his Newton's laws are the key to understand how planes fly. It's a bit less intuitive, but this is actually how it works. Newton's law, 3 laws. Everybody seems to know the law number 2. We are actually interested by law number 1 and law number 3. Law number 1 says if you take an object at still, not moving, and if you don't apply any force to it, the object is going to stay still. Other variant of the first law of Newton, if you take an object moving in a rectilinear, in a line at constant speed, if you don't apply any force to it, the object is going to keep on moving in a line, in a straight line, at constant speed. So, if an airflow changes direction, or speed, it means a force was applied to it. And the third law of Newton says, if I apply a force to, let's take, I don't know, a mouth. I'm holding this mouth. My hand is having a force upwards against the mouth, which is equal to the gravity, the weight of the mouth. The force of my hand on the mouse is equal to the force of the mouse on my hand. That's the third law of Newton. Action, reaction. In other words, you take a wing, hair, the wing is having an action on the hair, which makes the hair goes downward. The reaction from the hair to the wing, that's lift. And that's how Newton is going to help us to understand what Bernoulli can't explain. Especially Bernoulli doesn't explain how the angle of attack plays a vital role. Okay? So, Newton approach, hair goes this way, it's moved downwards. The wing has got an effect on air. The wing has got a force, puts a force on the air which goes downwards. The reaction, which is a force from the air to the wing, that's our lift, guys. Okay? So lift is actually proportional. F stands for proportional. Lift is proportional to the amount of air moved downwards. Okay? This is actually, I've got an example to explain it. This is the Coanda effect. You take a glass, just, normal glass, in your kitchen. You put it underneath a stream of water coming from the tap. The stream of water is going to follow the curve. It's going to follow well, you can see it on the diagrams. Whoop, that's it. The water is going to follow the stream. The stream of water is going to follow the curve of the glass. Same thing with air, is going to follow the curve of the wing. The water flow changes direction, the air flow changes directions, and the glass has got an effect. It's putting a force on the fluid, and the reaction is force on the glass. Likewise, the air goes downwards following the wing. The reaction is a force on the wing up, and that's the lift. That's the Coanda effect. It's the same thing as when you're in the swimming pool, swimming front crawl. You take a little piece of water, you squeeze it and pull it and push it behind you. And by making water move, you get a reaction and you move forward. Something like a gas turbine on a plane sucks air in, squeezes it, blow it away, and by making air move, you generate thrust. It's the same principle. Lift is nothing but a reaction from the air on the wing, and that's because the wing makes the air move downwards. I'm gonna leave you with the formula, and I'm not gonna explain it fully, but you've got bags of information on that on the net. Lift is equal to CL, the lift coefficient, times A, the area of the wing, times half rho. Rho is the air density, and V square is the true air speed. And that is it. CL is function of the angle of attack. So in this formula, you've got all the parameters you need to understand to actually understand why planes fly. And that's because the wing moves air downward. Okay, hope you had a nice video. You take care and see you later.